Good day. In this lecture, we will discuss the constituents of petroleum, focusing on their classification and chemical characteristics. By the end of this lecture, you should be able to describe the different constituents of petroleum and relate their structure to their properties. Petroleum, from petra meaning rock and oleum meaning oil, is also known as crude oil. It is a complex mixture of thousands of compounds including gases, liquids, and solids ranging from methane to asphalt. In its raw form, petroleum is not directly useful and its value comes from separating its components. Petroleum can exist in different physical forms. Crude oil, which is dark and viscous, condensate, which is lighter and more volatile, bitumen, which is semi-solid, and asphalt, which is solid. These forms reflect differences in the composition and molecular weight of your crude oil. Most constituents are hydrocarbons, but there are amounts of compounds containing nitrogen from 0% to 0.5%, sulfur from 0% to 6%, and oxygen from 0% to 3.5%. These affect fuel quality, corrosion, and environmental impact. In terms of the petroleum constituents, we have your hydrocarbons. So the first one is aliphatic hydrocarbons, and this includes your alkanes, your isoalkanes, and olefins. Your hydrocarbons can be classified into open chain or closed chain hydrocarbons. Each group differs in structure and performance. Alkanes are straight chain saturated hydrocarbons with a formula of CnH2n plus 2. They are major component in crude oil. However, they have low octane rating, meaning poor resistance to knocking in engines. We also have your isoalkanes, which are branched hydrocarbons with the same general formula as alkanes. Because of the branching, they have higher octane rating and better anti-knock properties. This makes isoalkanes more suitable for engine performance. Next, we have your olefins or alkenes, and they follow the formula CnH2n. They are not naturally present in the crude oil, but they are produced during the cracking processes, and they are more reactive and contribute to improve fuel performance. Next, we have your cycloalkanes and aromatics. So this falls under wing compounds. This structure influence stability and combustion behavior. Cycloalkanes. Cycloalkanes have the same formula as alkenes but are more stable. They are the second most abundant group in crude oil composition, and their stability makes them important in terms of the fuel composition. Next, we have your aromatic hydrocarbons such as benzene and toluene, and they are present in small amounts. However, they have very high octane ratings and they have excellent anti-knock properties. This makes them valuable for gasoline formulation. In terms of lesser components, petroleum also contain minor components such as sulfur, which causes corrosion and odor, nitrogen and oxygen compounds, and trace metals and salts. These are generally undesirable and must be removed during refining. Next, we have natural gas liquids, which are hydrocarbons found in underground reservoirs. They are important as feedstocks for petrochemicals being used to produce plastics, fuels, and other materials. Well, that concludes the lecture on petroleum constituent. Focus on how structure affects fuel properties, especially octane rating and engine performance.